Thank you, everybody. Good evening. As told by Madam, Vaijayanti, I am S.K. Das. I'm Executive Director here in SAIL. So, when you talk about the sustainability or when you talk about mainstreaming sustainability, when you talk about climate compliance, basically, I am pretty convinced that by now it is no longer a topic for this coffee table discussion. Rather, this sustainability, it has become a global movement today, and it's picking up momentum. But what is more important, that more and more need to be done. So to be a sustainable thing in every respect, we have to be a sustainable steel maker or like. If you consider steel as such as a product, is a very environmental friendly because it's got a infinite recyclability. But steel making as a process, it is not that environment friendly because I think it's not. Rather, it's not a. You can say it's not that benign. The steel making. A lot of other things are there, and if you are not having control over your process, so definitely its environment footprint will be very high. So considering that thing, so steel sector is always regarded as a hard to abate sector. Of course, there are. I'll glide through my these slides and all, and at the end we'll finally conclude what it is. So I am representing Steel Authority of India Limited, and if you consider Steel Authority of India Limited as a delta X, and you can get the entire picture of steel industry. Steel making basically a pyrometrological process, and it uses coal or a coke that is a derivative of coal just to meet its fuel need, and it's also used as a reductant. And obviously, the carbon footprint is very high. And if you consider the global steel industry, it contributes around 7.5% of the total emission. And in case of Indian steel, Indian scenario, that our this share is slightly more. It is around 11% of the total emission. And specific emission wise, it emits around 2.5 to 2.8 tons of CO2 per ton of steel being produced, and it's higher than the global average. That is around 1.8 because the process differences is they use more scrap, and that brings down their emission. So considering that steel industries have a very high environmental footprint, so we have integrated that sustainability into our business vision, and it is our priority that we want to see that even the most marginal element of this ecosystem is not affected by our operation. So with this thing, I want to share some slides, and I'll show you the different actions being taken by Steel Authority of India Limited to remain in the path of sustainability. Just I'm sharing my. Just a minute. My slides are visible.
Yes, sir, it is visible.
Is it visible, no? So, of course, that the topic of my today's discussion is sustainability in steel making, a hard to abate sector. So whenever we are talking about the sustainability, it has got certain challenges. So what are those challenges or different aspects of the sustainability that is which is coming in the way of for any industry to run in a sustainable manner? That is that different pollutions are there. They emit different type of these process gases and different dust and other pollution are there. Then water conservation is a big challenge. Then resource depletion, that is material efficiency is less in many of the industries. So earlier, the present this concept is circularity. Earlier it was the linear economy. So most of the things, this process waste, they are not being recycled. Now we are going for this recycling of this thing. So that way we are cutting down the use of this virgin material. Then there comes the biodiversity loss. Just to meet the industrial need, we are going for this cutting on forest and all, and other biodiversity, different we are this different elements and birds, their habitat is being lost. So that way we are affecting that biodiversity. And then the most important one is the climate change. Climate change is the biggest concern for today. I think by now everybody is concerned about this climate change. This climate change, I think we are the first generation to face the this effect of this climate change. And if you are not aware and we are not taking some actions, then we'll be the last generation to face the worst of this climate change. And then the green energy. So these are the different challenges for this sustainability. Now, another thing is that is the 3C word. What is the 3C word? So now, the world is in a path of warming. So just to contain this warming, different actions are being taken and different commitment, different pledges are in place. And we had different agreements like Paris Agreement, and subsequently different COPs. We have decided different protocols and these things just to bring down this, contain this warming within 1.5 to 2 degrees centigrade. But it is very alarming that even with these pledges in place, we'll end up with a temperature rise of around 3 degrees centigrade. So we have to increase or enhance our ambition, whatever commitment we have given during our Paris Agreement and subsequent COPs. So if you just see this graph, you can see this is the number of cyclones we had in the last decades. So in 1960 to 69, there was no super cyclones, but in the 70 to 79, there was one super cyclone. So then again, 90 to 99, there was two. And you can see the number of these super cyclones in a year in India, they are going up. And similar is the cases of different extreme weather conditions. So this is an indication that we are already a prey to this climate change effects. So if we are not rising to the occasion and taking actions, so we are definitely going to end up somewhere where nobody can fetch us out of this crisis. So this is what in the last conference of parties, that is COP26 at Glasgow. So some enhanced ambition India has declared just to bring down the global temperature rise. And I think that the clarion call given by our Honorable Prime Minister, that set tone for the other countries also to enhance their ambition, and we are expecting something good in the coming days. So, and what is most important that we have committed net zero by 2070, and steel industry and most of the steel industries in India, and of course SAIL is also there in the line. We have drafted our net zero roadmap, and by 2070, and different actions have been taken up. So if you're coming to our this net zero roadmap, so we have just divided into three distinct time zones. So you have started all our activities, this climate change related awareness and these activities, they have started way back in 2005. And 2005 to 2022, that was our first phase of our decarbonization. And in this period, we have saved around 19% of our emission. We are somewhere around 3.05 tons of CO2 per ton of crude steel. From there, we have brought it down to 2.51 tons of CO2 per ton of crude steel. But in the next phase, from 22 to 2030, that phase is very vital. We have set a very challenging target of reducing it by 20% further. So though our NDC commitment is 2.3 ton per ton of crude steel as per the Paris Agreement and as decided by the Ministry of Steel, but our subsequent to the COP26 at Glasgow, we have enhanced our ambitions like anything, and by 20% reduction in this emission will be somehow around 1.99 ton of CO2 per ton of crude steel. I think that is very challenging, and we are definitely putting our all efforts to meet this target. And post 2031 period, we will go for this deep decarbonization processes, and by 2070, and I'm quite hopeful that even before that we'll reach our net zero target. So for achieving this this target, we have introduced many state-of-the-art technologies here in the SAIL. And it has resulted in if you take in another absolute terms, we have saved around 88 million tons of CO2 during this period. And it will further go down. I think this year it is still less. It has come down below 2.5. And we have, most importantly, you have made a carbon sink of 21.5 million trees just by plantation. And you have also gone for restoration of the degraded landscape also in the SAIL. That I'll come later. So if you see that this low carbon steel decarbonization, there are certain first areas for us just to bring down our carbon footprint. First one is the reduction with coke rate. What is coke rate? I told you in the during our discussion that we use coke in blast furnace for conversion of this iron ore to this hot metal. And if you are consuming more coke, then your emission will be more. So our first priority is to reduce this coke rate. And for that, two of the most important initiative is increasing the prepared burden. We are using more prepared burden, we are using more pellet and sinter and other things, so that our prepared burden is more, and so that will reduce our coke consumption. Then maximizing PCI injection, that is pulverized coal injection, that to supplement this entire process. So if you increase more PCI, your carbon footprint will come down. So that we are already exercising. Then next is increase in share of renewable energy. We are trying to increase our share of renewable energy or these processes. Then process efficiency increasing. If you increase your process efficiency, of course, your this raw material consumption will come down. So different best available technology, whatever available across the globe for the steel industry, we are adopting those facilities in our all upcoming facilities, and whatever old facilities are there, we are trying to retrofitting all these newer technologies. Then promotion of circular economy, material efficiency, solid waste management. Further details I'll come up in the subsequent slides. Then recovery of all possible heat loss. There are heat losses during the process. So we are practicing all these energy saving processes. And another area where we are venturing in, that is a low temperature heat conservation. That is, it is the normal practice is that whatever heat is lost, which are at very low temperature, it is difficult to capture those heats back into the process. So we are having some technologies. We are tying up with some companies for tapping the low temperature heats. And one of the transition before we go for this hydrogen steel making, that will come later on, the deep decarbonization phases. So we are before going to that, as a changeover process, we are going to inject coke oven gas, cold bed methane gas, and natural gas in blast furnace to reduce our footprint during this hot metal making. And introduction of carbon capture and utilization storage. So we are going in a big way for this carbon capturing and its usage in the downtime, different value-added product. So that will somehow reduce our carbon footprint. So it is one of our initiative for this carbon capture and sequestration. So we have got different integrated steel making facility in different areas. So two of our steel making facilities that is in the eastern part of this country, that is in Durgapur and Burnpur area, and that area is better known for its CBM, this storage and CBM availability in the mines, this coal seams. So we are trying to. It is you have. I think you have heard about enhanced oil recovery for sequestration of the CO2. Here we will go for this ECBM, that is enhanced cold bed methane recovery. So what we are doing, so different waste gases we are generating in the steel plant, will capture the CO2 from there. Otherwise, it goes to the atmosphere. We will process it and store it at certain facilities being to be developed, and we will take it to the CBM wells, and CBM extraction is going on. So either through that pipelines or this special CO2 carriers, and will inject this CO2 inside the CBM oil, and that will further increase the CBM this CBM extraction from this well. What will happen? This CO2 gas will go to the coal seams, and that will push the CBM to come out, and that will be sequestered there, and we can get rid of this CO2, and it will not go to the atmosphere. And if we face some problem in enhanced CBM reduction, then too I will go for only simply for this storing of this or sequestration of this CO2 in this cold bed methanes. So recently we have inked a MOU with IIT Kanpur, the Center of Excellence. They are doing some work on this thing, and they will basically they will support us. They will facilitate this entire carbon capture, utilization, and sequestration process, and that will be done with one of our steel plant, that is in East Coast Steel Plant, that is in Asansol area of West Bengal. So you can see the head of Center of Excellence, Mr. Vikram Vishal, and our director in charge steel plant. Of course, I am also there in this MOU signing process. So next is our target is carbon neutrality. So what we'll do, we'll go for that is this still now we are using coal or coke as a reductant or fuel for this thing, our steel making process. So in our deep decarbonization journey, or our journey to carbon neutrality, we'll be using we are trying to use this H2 as a reductant, and for that we'll use renewable energies for our this electrolysis of water, and we'll get H2, and that will be used in our this iron ore reduction. We'll get molten iron and H2 molten iron or H2 DRI, that is directly reduced iron, and further we'll use our green energy to run some electric arc furnaces, and then down the line our finished products will be produced. That is our next scheme. So basically some challenges are there in our this deep decarbonization journey. What are those challenges? First of all, this technology, what we are talking about, that is in a very nascent stage. This R&D initiative is a very nascent stage. And next thing is, most of these R&D initiatives have been taken up at the advanced economies. And that has to be brought to our Indian context, and so that it is suitable for our perspective, in Indian perspective, it is suitable. So that we are also trying to have some collaboration with overseas technology providers, overseas institutes, and Indian Institute of Jaipur to have a collaborative approach, so that we can also do some R&D in this area, and we can just facilitate or this early coming up or early maturity of this is at a very low TRL level. All this R&D is a very low TRL level, so that we can reach the high TRL level with a minimum possible time. Then is your integrated CCUS, mass for residual emission. But you cannot make the emission zero from the steel making processes. So we have to have some CCUS facilities, whatever, just to just meet this carbon neutrality equation. Yeah, either you do, if you do going for the CCUS, you cannot reach that carbon neutrality. And third biggest concern is our cost. Cost is 3 times more than our BOF crude. One MTPA plant cost around $3 billion US. So we have to think of that one before we are switching over to that newer technology. And hydrogen, that has to be, that green hydrogen, that has to be available at a affordable cost that can support the this economy of our this production. That has to be between $1 to $2 per kg. And then only these things can be possible. And once these things are already established, then we'll gradually phase out our 20th century blast furnaces and adopt these things, and we'll go towards our neutrality, carbon neutrality. So our these priorities are wide coverage of CCUS to take care of residual emission, international collaboration, what I talk, breakthrough technology developed and developing economy, production of advanced high strength steel, because if you if you increase your strength of your steel, you can use lesser steel, and you can have the same expected this whatever this intended for, you can have with lesser steel, and your steel consumption will come down, and accordingly your carbon footprint will come down. And then gradual shift to the alternate steel making such as H2DR and AER. So this direct reduction what we're talking about, basically this is just a schematic diagram of this direct H2DRI process I'm showing. The iron ore is being converted to the pellet, and wherever there is a need of energy, we are using, they are using this green energy. Then electricity, green electricity is being used for this electrolysis of this water, and then hydrogen is used, and this hydrogen stored, and this hydrogen is used for this reduction of this iron production. Then whatever steel is produced through this EAF, electric arc furnace, and here also this green energy is used. And down the line, we are getting the crude steel and slab, and that is ultimately converted into finished steel products. And this is another initiative taken by this Tata Steel in their IJmuiden facility in this Netherlands. That is also a environment friendly this process. Here we are, it has got a we call it the Hyserna process. That is, it has got a cyclone converter furnace CCF and a Hismelt vessel. So it has got an potential of saving CO2 reduction compared to this conventional BOF by 20% without CCS, and with CCS it can go up to 80%, the possibility of CO2 reduction by 80%. In that is the different campaigns have been taken with different technology setups. And in campaign 5, with steel scrap and biomass use, CO2 reduction was they have achieved around 50%. So it is a very promising technology, and we are expecting the commercialization of this technology so that we can also adopt such type of technologies in our process. So we are also in talk with different technology providers. We want to have a small pilot plant with 100-ton capacity. One of our facilities where we have got some encroachment-free land, and where we are planning to have some solar plant, and whatever green energy produced, that will be used for our electrolysis. This is around 200-300 kilometers from our stay Calcutta, and there we have already have some base feasibility study for this type of project. So we have leading technology providers like Tenova and Danieli. These people are being contacted. So here also same thing, we are trying to have some H2DRI, and then whatever this continue casting, and ultimately our final aim is to have some auto grade steel from this unit. And this is a whatever we are contemplating, that is in a very small scale, that is a 100-ton capacity. And if it is successful, then we'll upscale it and we'll go for some bigger capacity, this type of green steel facilities in our fold. So now coming to this circularity and this sustainability. So this number of times I've told iron steel making is a pyrometallurgical process, and a lot of byproducts are being generated like liquid, solid, gaseous, or radiant heat energy. So like industrial effluent and sewage, slag, dust, sludge, mill scale, scrap used in factories, coke oven gas, BF gas, and BF gas, and radiant heat. These are the byproducts of our this process. So first of all, this water, conservation of water. So India is a as far as this water is, it's a stressed country. And globally, if you know, only 4% of the fortunate people, they have got access to this clear water. So conservation of water is the biggest call of this day. And to be on the path of sustainability, we have to have some measures to conserve the water. So then another big question is whether this recycling or this thing water saving scheme, do they adapt to our initiative to a CO2 data? Definitely it is, yes, because if you design correctly, we can dependency on the fresh water drawal by 90% in any of the steel making facilities. And it is a global report that there is around 40% of the clean water is lost due to leakage. And though these recycling processes are energy intensive, but it is much less energy consuming than the drawal of fresh water and then processing and using it in the process. So by water conservation, also we can do something towards our CO2 reduction. So coming to our water conservation initiative, that is some integrated. We have got an integrated water management system, and that focuses on the following things. That is, first of all, this building awareness. We take regular campaigns. 1 month of the year is being observed as a water conservation month. We conduct different seminars. We distribute leaflets and other awareness campaign, whatsoever can be for our people, our employees, and all our stakeholders are brought to this field, and just to build awareness towards this water conservation. And then next time is this maximize recirculation of water, aiming towards zero leakage discharge. And I'll show in the next slide our initiative, what we have already achieved. Effluent treatment plants to maintain the effluent quality as per our statutory norms, because we are not in a zero leakage discharge position right now. We are trying to achieve that one. But till that time, whatever effluent is going out of our campus, we want it to be strictly adhered to the statutory norms. And for that, we are running very efficient effluent treatment units. Then we are going. We have gone in a big way for this rainwater harvesting and minimize evapotranspiration transmission. For that, we have gone for this closed loop cooling systems. So I was talking about this recirculation scheme. SAIL created a potential for saving around 236 million meter cube per year through wastewater treatment and recycling scheme. Already we have commissioned 109 million meter cube per year of this water recirculation scheme, and another 127 million meter cube per year are at the implementation stage. And within I think in the coming 7 to 8 months, we'll be completing all these projects of balance is 127 million meter cube per year. So another initiative is where what we have attached to our integrated steel plant. We have got big townships where more than lakhs people are there staying. So we have got for this township, we have got efficient sewage treatment plant, or whatever water we are getting out of this treatment. We are using it for our process as a process water, and that thereby we are reducing our dependence on the fresh water or draw from the natural source. Then comes I was talking about this energy efficiency, waste energy saving. So some of the initiatives, like we have in our coke oven facilities where we convert this coal to coke, we have gone for this coke dry cooling plant. And in blast furnaces, we have gone for top pressure recovery turbines. So these facilities, they can generate 40 megawatt of power together. Otherwise, earlier this type of things were not there. That the entire this 40 megawatt power we have lost so far before installation of these units. Now we are getting 40 megawatt of power out of that. You can say it's a waste energy we are recovering. So another thing is there, if you are using this coke dry cooling plant, then you are saving a lot of energy also, because conventional coke quenching facility is through sprinkling of water that uses a lot of water. So these facilities are already there, our newer facilities, and we are trying to retrofit this type of technologies in our older setups also. So we are going in a big way to save energy through these processes. So then we are having this blast furnace stove and sinter coolers. We have gone for waste heat recovery. We are recovering BOF gas and we are using it in the downstream processes. Similarly, for the blast furnace gases, also we are using in our power plants and replacing our, it is reducing our use on pulverized coal for this power generation. And another big thing we have done, that is we are introduced this torpedo ladders for carrying this hot metal from our blast furnace to down the steel melting shop. This entire route we used to carry this hot metal in the open ladders, and lot of energy loss was there. And now this torpedo ladle, that there is no heat loss, and a lot of energy is being conserved by that way. And we have adopted this hot railing process. So we are eliminating the process of reheating of this our feedstock like billet or blooms before taking this rolling process. So it is also saving a lot of energy. Coming to our solid waste utilization, I am talking about one of the big challenge for this sustainability is material efficiency. So we have gone in a big way for this circular economy or circularity, and all the 4R principles are being implemented here. So our solid waste utilization, whatever process waste are there, at around 95%, and our solid waste mostly constitute our BF slag and BF slag. Our utilization of our BF slag is around 100%, and our BF slag utilization is a bit less, that is around 69%, and this is a big concern for us, because almost 1 million ton of this BF slag they remain unused every year, and we are trying to find some areas, or we are exploring areas where we can gainfully utilize this BF slag, and of course in an environmental friendly manner. So for utilization of BF slag, we are using this BF slag in downstream cement making facilities. This nowadays most of the cements are you call it Portland blast furnace slag cement or Portland slag cement, and by using this slag, we can reduce the this energy consumption by 40%. Similarly, our CO2 reduction from our this cement factories have reduced by 40% by using this slag. So it is a highly environmental friendly initiative. For that, what we have also done something in our facilities, because just to make your BF slag suitable for cement making, you have to have some state-of-the-art facility that is called this cast out slag granulation facility. So gradually we have adopted this system and in some newer facility, and we have retrofitted in our old setups in all the blast furnaces. Around we have got around 18 running blast furnaces across SAIL in our 5 integrated setup. In all the setups, we have got this state-of-the-art slag granulation facility, and which is making our BF slag suitable for our downstream cement making facilities. And we are exporting this slag also to our neighboring countries, and we are getting some foreign exchange out of that also. So in one side, it is helping in run us in an environmental friendly manner. At the same time, it is also supporting our highly stressed bottom line also. As I told, the BF slag utilization is a concern. Part of it is being recycled in our process, but most of that around 31% goes unused. So we are exploring different avenues for its gainful use. One of the most promising use of this blast furnace slag is in the agricultural feed, because we have got out of this 157 million hectare of cultivable lands in India, around 49 million hectare of this land is acidic in nature. So that is around 80% of the total geographical area. So which limits crop production. So in this BOF slag, we have got some content. So that is basic in nature. So we can use this BOF slag for amelioration of our acidic soil. And the only concern is the presence of chromium there in BOF slag. That has to be less than 150 ppm, and sometimes it goes beyond 150 ppm. So we have undertaken one project with IARI, Indian Agricultural Research Institute, that is, and our Ministry of Steel is also there, and Agriculture and the Fertilizer Ministries, they are also facilitating this project. And we as an industry partner, ourselves, JSW and Tata Steel, we are the industry partner for this project. So if this project, this BOF slag will be used as a fertilizer in this acidic kind of soil, and this has got a heavy potential of offtake of this BOF slag, 49 million hectare. Even if you use 1 million ton per hectare, then it is a huge quantity. So 49 million tons of BOF slag can be used in our agricultural setup. And we have got one, there is a huge potential. We have got, I told you, 1 million ton of surplus BOF slag. So we are quite hopeful that once it is done, we can gainfully utilize our this agriculture, and it's a good environment friendly initiative from our side. And you can see the because IRI is carrying forward this project across 8 of its sub-center. So product trials are being done, and that's it's quite encouraging. If you see some of the photographs I have taken during our recent visit, and progress of this project is quite encouraging, and I'm quite hopeful that this will within a year or two will start getting benefit of this thing. So you can see the different areas. This is from Prantnagar, and earlier one is at I think that is Dharwad. And similarly in Wellington, also in Bhubaneswar also, and in the northeastern region also, some different these trials are being taken. So we are using it in the road also. This BOF slag we are using in the road under Pradhan Mantri Gramin Service Yojana. And recently around 1.54 million tons of BOF slag is being used from 1 or 2 of our steel plants for this road making facilities. Another area that is very promising for reduction of this carbon footprint is use of steel scrap. It has got immense potential. If you use 1 ton of steel scrap in the steel making, then it saves around 1.1 ton of iron ore, 630 kg of coking coal, and 55 kg of limestone. But only problem is in India there is a big problem for availability of steel scrap. Still in last year also we had to import around 7 million ton of this steel scrap from abroad for meeting our this EF need, because around 38 to 40% of our steel is still made through this EF route. So for that, Government of India has come out with a policy that is steel scrap recycling policy. That is a hub and spoke type of model. There across India, different collection center will be there, and that will be this collection center will be feeding to this processing unit. Against each of the processing unit, there will be 4 this collection center. So altogether, for presently for this 7 million ton, we are expecting around 300 collection center and 300 processing 300 collection center, and around 130 processing unit we are contemplating immediately for this thing. And already Tata Steel has gone for a setting up a 0.5 million ton of processing center at Haryana. So another thing is use of this iron ore fines and sludge. So earlier you told you one of our one of the priority is to use more agglomerated mass in our blast furnace, blast furnaces, and for that we are for this using these fines and micro fines, and from the tailings we are planning to have around 7.5 million ton of capacity of pellet plants at our different areas, like in Raurkela Steel Plant, ISCO Steel Plant, Goa Iron Ore mines itself, and Dali mines. So that will facilitate us to use more agglomerated mass in our blast furnace. And then again, this we have one for the slime beneficiation. While you are washing your uh, this iron ores for beneficiation, some finers, iron ore that they are getting accumulated and they are being taken to the tailing ponds. That is, and where this water settles and again used for this cleaning purpose. The slime also contains a lot of Fe. So we are trying to give beneficiate this slime, and so that Fe content of this slime, which is around 50 to 52 to 55%, we are trying to bring it up to the level of 62 to 64%, so that it can be converted into pellet, and again that can be used in our blast furnace for hot metal making process. And in some of our plants, that silica, that is an unwanted thing in our this thing. This iron ore finds that feedstock. So that gang content, we are trying to reduce the gang content through installation of silicon reduction project already in our one of our mining area, that is Tali Rajara mining area in near Bhilai steel plant. We are installing 1 million ton per annum silicon reduction plant. So these beneficiated things will definitely improve our carbon footprint. So again, this while we're discussing the challenges for this sustainability, one of the most biggest concern is our degradation of this biodiversity. For steel making, we go for a lot of excavation and mining. So ultimately, you are degrading your this land types. So as a conscious and environment conscious company, SAIL has gone for eco-restoration. It is not simply plantation and all. It is eco-restoration of our degraded mines, because some of the abandoned mines where this mining work is over. So like one of them is in Purnapani in Orissa. So we have gone for eco-restoration in association with Center of Environmental Management of Degraded Ecosystem, Delhi University, and Professor Babu is heading that one. So there we have successfully restored around 250 acres of old barren overburden dumps. Whatever overburden was dumped out in the near this mining site, that has been converted into a 3-storied foliage. You can see this was the scene before we started this eco-restoration job, and now we can see forest ecosystem developed. And after this minded area, you can see such a good greenery there, and it has become a example for all the miners there. And we are showcasing this one, and different miners of the nearby areas, they are coming and they are also trying to replicate it. And we are also taking up other restoration areas in our 2 other mines in Kiriburu and Meghatoburu area, that is near in the state of Jharkhand. They are also going for this eco-restoration job. So you can see this was the overburdened this area before this restoration, and this is after that one. And we have converted this mine void also. We have converted into a ecosystem where every year we are that is giving some vocation to this local people. They are going for fishing and all in this mines void. That is a complete ecosystem there. So with this all effort, we could save our specific energy consumption by more than 7%. Earlier, it was 6.86 gigacalorie per ton of steel in 2011. Now it is 6.36, and the specific CO2 emission reduction at already 20 is come down by 90%. So another initiative, like with the Tropical Forest Research Institute, Jabalpur, we have gone for carbon sequestration through afforestation at Raulkela Steel Plant. So that they are taking up some project, they're seeing which variant of the this vegetation has got the maximum growth and maximum CO2 facilities. They are first mapping the CO2 concentration in the area, and they are experimenting with the local varieties of different trees, and whichever this species is giving maximum storage, the CO2 sequestration potential, we are going. They have indicated that 12. They have segregated that 12 varieties, and where we could save some. This is a small patch of 10 hectares of land, and with this thing, we will be replicating it to the other areas also. and we try to go for more sequestration is through this biological means, that is this through plantation of appropriate variety in different parts of cell plants. And as a part of our green power and energy efficiency, we have already contemplated installation of 200 megawatt floating ground and rooftop power plants are being planned, because we have got large water bodies in all our integrated steel plant facilities. And as because land is a big constraint there, we are trying to utilize those water reservoirs for setting up of this floating type of solar power plants. Already 4 megawatt it is being installed. I think within a month or two it will be commissioned, and another 196 megawatt of floating power plants are at various stages of completion. So we have converted all our conventional lands through this LED system. Or more than 7.5 lakhs of LED lights are already being replaced. These conventional lights, and another 3-4 lakhs will be completing by another 12 to 16 months. And wherever possible, we have introduced these VBBF drives in our motors to improve our energy efficiencies. And one unique thing which we have done, the Stockholm Convention, they have banned the use of polychlorinated biphenyls for after 2028. So polychlorinated biphenyl is a synthetic oil that is being used as coolant in most of the conventional transformer being used in some of our plants. And we have got a huge stock of this type of transformer. So as per this directive, now we are going to set up a facility for environment friendly disposal of this polychlorinated biphenyls. So that setup is coming up in our near our Virai steel plant, and it is jointly funded by UNIDO and SAIL. UNIDO is funding for the main equipments of this facility, that is Plascon, and they are giving a aid of around $8.34 million, and our contribution is around 136 crores for setting up the static facility. And once this completed, that will not only help SAIL in disposing these polychlorinated biphenyls, but also help in all the nearby industries for disposing their PCB contaminated inventories in a environment friendly manner. Basically, PCB is a persistent organic POP, you say, pollutant, and it induces is carcinogenic in nature. It induces cancer if your exposure is too long. So it's a very noble initiative from SAIL. So it is at the final lap of commissioning. So I think within a month it will be commissioned, and it is a showcase project for not only for SAIL, it is for UNIDO and MOFCC all together. It's a very great initiative from SAIL. And so some way forwards for SAIL is like improving material efficiency, enhancing use of scrap, near net safe casting. Near net safe casting means you don't have to use more energy. Your casting is near the final shape, so you need lesser energy for this final rolling operations. Then organic ranking cycle for a solution to capture low temperature heat. I was talking about this thing in our initial discussion. Then breakthrough steel making technologies, use of hydrogen, that is in our on cards, and integrating carbon capture, utilization, and storage in the process, and finally the green power. These are the way forwards. So I think it's a big thank you to all of you for a pleasant hearing. Thank you very much.